Hello and welcome to System Design Driven. In this video, we will design a system for tracking user activity on a website and providing personalized recommendations based on their behavior. Let us understand this problem better. Imagine you are working for a company that runs an online marketplace for buying and selling various products. Your task is to build a system that tracks user activity on the website and recommends products that users might be interested in based on their behavior. What are the constraints? The system needs to be highly scalable and reliable, as the website has a large number of users and a high volume of traffic. Additionally, the system needs to be cost-effective, as the company wants to minimize their expenses. Next, we will try to break down this problem. To achieve this goal, we can break down the problem into the following steps. 1. Data collection, track user activity on the website and collect user behavior data. 2. Data storage, store the collected data in a scalable and reliable way. 3. Data processing, process the data to identify user preferences and interests. 4. Recommendation generation, generate personalized recommendations for users based on their behavior. 5. Recommendation delivery, deliver recommendations to users in a timely and efficient manner. Before we move on, if you have liked it so far, please subscribe to our channel and give a like. Also leave a comment on how we can improve and what other topics you would like to see in this channel. Thank you. Now that we have broken down the problem, let us make some design decisions. 1. For data collection, we can use a combination of server logs, browser cookies, and JavaScript to track user activity on the website. This data can include user clicks, searches, and purchases. 2. For data storage, we can use a distributed database like Cassandra or HBase to store the user behavior data. This will ensure scalability and reliability. 3. Now in data processing, we can use machine learning algorithms like collaborative filtering and content-based filtering to process the data and identify user preferences and interests. 4. We can do the recommendation generation based on the identified user preferences and interests. We can generate personalized recommendations for users using machine learning algorithms like matrix factorization or neural networks. 5. How do we do the recommendation delivery? We can deliver recommendations to users via email, push notifications, or on the website itself. Let us discuss about scalability now. To ensure scalability, we can use a distributed database like Cassandra or HBase to store the user behavior data. We can also use a distributed computing framework like Apache Spark to process the data in parallel. Additionally, we can use load balancing techniques to distribute the recommendation generation and delivery workload across multiple servers. Moving on to reliability. To ensure reliability, we can use data replication and fault-tolerant techniques in our database. We can also use data backup and recovery mechanisms in case of data loss. Additionally, we can use monitoring tools to detect and resolve any system failures or performance issues. How do we manage cost? To minimize costs, we can use open-source technologies like Apache Cassandra and Apache Spark. We can also use cloud-based services like AWS or Google Cloud Platform to host our system. Additionally, we can use cost optimization techniques like spot instances and reserved instances to reduce our infrastructure costs. Let us discuss trade-offs. There are several trade-offs to consider when designing this system. For example, using more complex machine learning algorithms for recommendation generation may result in better recommendations, but it may also increase processing time and cost. Additionally, using more advanced data storage techniques like sharding may improve scalability, but it may also increase system complexity. Let us deep dive into low-level design. Data structures. To efficiently store and retrieve user behavior data, we can use hash tables and binary search trees. We can use hash tables to store user behavior data based on a unique identifier like user ID or session ID. This will allow us to quickly retrieve user data using constant time complexity O1. We can also use binary search trees to store user behavior data based on timestamp or event type. This will allow us to efficiently retrieve and process user behavior data based on time range or event type. Algorithms. To process the user behavior data and generate personalized recommendations, we can use machine learning algorithms like singular value decomposition, SVD, or alternating least squares, ALS. These algorithms are commonly used in collaborative filtering, a popular technique for generating recommendations. Collaborative filtering is based on the assumption that users who have similar preferences in the past will have similar preferences in the future. SVD and ALS are matrix factorization techniques that factorize the user-item interaction matrix into lower-dimensional matrices, which can then be used to estimate the missing entries in the matrix and generate personalized recommendations. To implement SVD or ALS, we can use Python-based frameworks like TensorFlow or PyTorch. These frameworks provide efficient implementations of these algorithms and allow us to scale to large datasets. System architecture. The system architecture can be divided into two main components: data processing and recommendation generation. The data processing component will collect and store user behavior data in a distributed database like Cassandra or HBase. The recommendation generation component will process the user behavior data using machine learning algorithms like SVD or ALS and generate personalized recommendations for users. The recommendation generation component can be deployed on a separate set of servers to ensure scalability and parallel processing. To ensure reliability, the system can use data replication and fault-tolerant techniques in the database. For example, we can use Cassandra's replication factor to replicate the data across multiple nodes to ensure availability and durability. We can also use monitoring tools like Nagios or Datadog to detect and resolve any system failures or performance issues. Here are some questions which interviewer can ask and the answers for it. 1. How will you ensure data privacy and security in the system? To ensure data privacy and security, we can use encryption techniques to secure the user behavior data during transit and storage. We can also implement access control mechanisms to restrict access to sensitive data. 2. How will you handle cold start problem, i.e., when a new user has no historical data? To handle the cold start problem, we can use content-based filtering, which recommends products based on their attributes rather than user behavior. We can also ask users to provide some initial preferences during the registration process to jumpstart the recommendation generation process. 3. How will you handle the sparsity problem, i.e., when users have very few interactions with the website? To handle the sparsity problem, we can use matrix completion techniques, which estimate missing entries in the user-item interaction matrix based on the observed entries. We can also use hybrid recommendation systems, which combine different recom. How would you handle a sudden increase in traffic on the website? Answer. To handle sudden traffic spikes, we can use autoscaling techniques to dynamically add more servers to our system. We can also use caching mechanisms to reduce the load on our database and improve response time. 4. How would you handle data privacy concerns? To address data privacy concerns, we can implement data encryption techniques like SSL/TLS for data in transit and data at rest encryption for sensitive user data. We can also implement user authentication and authorization mechanisms to ensure that only authorized users have access to the data. 5. How would you handle data inconsistencies or conflicts in the database? To handle data inconsistencies or conflicts in the database, we can use techniques like versioning and timestamping to keep track of changes. We can also implement locking mechanisms to prevent multiple users from modifying the same data simultaneously. 6. How would you handle recommendation accuracy issues? To improve recommendation accuracy, we can continuously refine our machine learning algorithms and data processing techniques based on user feedback and data analysis. We can also incorporate additional data sources like social media activity and user reviews to enhance the recommendation engine. 7. How would you handle system failures or downtime? To minimize system downtime, we can implement disaster recovery and business continuity plans. This can include automated backup and recovery mechanisms, redundant servers, and failover mechanisms to ensure that the system remains available even in the event of a failure. 8. How would you ensure that the recommendation engine is fair and unbiased? To ensure fairness and avoid bias in the recommendation engine, we can implement techniques like diversity constraints and balance metrics to promote a diverse set of recommendations. We can also incorporate user feedback mechanisms to identify and address any potential biases in the system. Thank you for watching this video on designing a system for tracking user activity on a website and providing personalized recommendations based on their behavior. We hope you found it informative and helpful. If you liked this video, please give it a thumbs up and subscribe to our channel, System Design Driven, for more content like this. We would also appreciate if you can post your comments about this video and what other topics you would like us to cover in the upcoming sessions.